Hello friends, this video on classification of elements part 4 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 3. Now let's understand the Mendeleev periodic table, the best periodic table I can say, the best effort. So this guy, what he did was he arranged the elements based on their fundamental properties, atomic mass, and also based on the chemical property. But chemical property was given the first priority. So at that time there were 63 elements known, so his work was on this 63 elements. He first tried to find the relation between atomic mass and the chemical and physical property. And to find the chemical properties relationship, he selected hydrogen and oxygen because they were very reactive and they formed compounds with most of the elements. So he reacted most of the elements with hydrogen and oxygen, and the way it reacts with hydrogen and oxygen, for example, this is some metal X and it reacted with hydrogen, it gives something, and X reacted with oxygen, it gives something, right? It may be Ra, maybe XH, maybe XH2, right? Maybe in this case, maybe XO, it can give X2O, it can give XO2, right? It can give X2O3 based on the property of the element, right? So it can react in different ways. So similarly with hydrogen also it can react in different ways. It can give XH3, it can give XH4. So based on the reaction of the element with hydrogen and oxygen, he grouped the elements, correct? And then he also used the atomic mass to arrange them, correct? So that is the formula of hydrides and the oxides which he get, the hydrates and the oxides formula which he get, was one of the critical parameter for classification of the element. So what he did was actually he took, for example, 63 elements, right? He took 63 cards. In each of these cards he wrote this element name. For example, the element name is X, and this guy found some hydride XH and some oxide XO2, let's suppose, right? And atomic masses, let's suppose 58, let's anything. So this guy, he created cards like this. He created 63 cards like this with all the 63 elements name and all the hydrides and oxides and all the atomic mass. Once he had all these values, right, he know all the 63 elements name, he know the atomic mass of all the 63 elements, he know the hydrides and the oxides form. Now he grouped these elements based on these hydrides and oxides. They are the critical thing here. See, if you see the last one, the Newland's law of active, he arranged based on the atomic mass alone, right? So his parameter was atomic mass, and then he found that they have similar chemical property. But this guy, for him, the critical thing is chemical property, and then he's trying to arrange the atomic mass, right? And if he finds some missing objects, he has created gaps also in the tables. We'll explain that, but let's understand that both have a different approach. In the Newland's one, what he did was his primary concern was the increasing atomic mass, and then he found that coincidentally they have repetitive chemical property. For this guy, the critical or the main thing was it should have same properties, chemical properties, that is the kind of hydrides and oxide form should be similar, and then the second critical thing was the atomic mass, correct? So he sorted these elements based on the similar properties and observed that most of the elements got a place in the periodic table and they were arranged in the order of atomic mass, increasing atomic mass. So he was able to arrange them, correct? And he also observed the periodic recurrence of elements with similar physical and chemical property. That's what Newlands have observed. He also observed here also, correct? And on basis of all these experiments he did, he gave a periodic law, right? And he stated that the property of the elements are the periodic function of the atomic mass. This is the law he gave. This law is called Mendeleev's periodic law. It says that property of the elements are periodic function of atomic mass. Please note it's atomic mass. We don't need the atomic number now because atomic number is not even discovered by this time, right? Because the electron itself was not discovered. All this atomic mass which we use here is all found by the chemical reactions, because the base of all this was the Dalton theory. John Dalton gave this theory in 1804, where he told the mass can neither be created nor can be destroyed, and that stoichiometry equations they found, the chemist found a lot of atomic masses, and these was the atomic mass that was used by Mendeleev. I hope it is clear to you. So what he has done was he reacted these elements with hydrogen oxide. He found different hydrides, different oxides, and based on the hydrides and oxide found, he clubbed these elements, right? And then he arranged these elements based on the increasing atomic mass, keeping in mind that all this form which forms similar hydrides, similar oxides are in a similar group. I'll show you the picture with that. I think it will be more clear. For example, if you see the hydrides can be R2O kind. Instead of X, they are using R here, or RO, R2O3, RO2, R2O5, RO3, R2O7, and RO4. So these are different kinds of hydride he found, and then he clubbed all these elements, right? And then these are oxides. For hydrides, RH, RH2, RH3, RH4, RH3, RH2, RH. These were the hydrides. So based on these two, he clubs. For example, for these combination, he found these many elements. So he clubbed all these into one group. Correct? All this into one group. All this in one group. So he grouped elements like this. Correct? And then if you see, he called his vertical columns as groups. So these guys were all groups. So group 1, group 2, group 3, and these were all periods, right? They are periods. He called this, used this word groups and periods, which are also used in the modern periodic table. So with this, if you see, everything is atomic mass here, hydrogen atomic mass, and then if you see, there's a lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, all the atomic mass, right? And based on the properties, this was the kind of periodic table he found, which was pretty good. Very few limiters in that, but it was very good actually. So we'll explain the merits and demerits of this periodic table. So let's do this. Hope you understand how he found this periodic table. So let's understand the achievement of this Mendeleev periodic table. First thing is predicted some of the elements which are not discovered at that time, because when he arranged the elements, he found that some elements are missing, because some of the elements atomic masses were missing, and then he guessed it. He guessed that okay, there will be atomic element which will be found in near future, which should have atomic mass of 68, and he called that guy as Eka aluminum because it used to come before aluminum, and that element was found in future, and we call that element as gallium. And he also guessed the formula of oxides and chlorides. If you see, he guessed that particular element which will have a formula of E2O3 based on his periodic table, and that's what it was. He also guessed the formula of chlorides or hydride to be like this, that is ECl3, and we found that gallium also follows the same suit. So he guessed the existence of some element which we not discussed at the time. Not only the existence of the element, but also the chemical property of the elements. He could predict properties of several elements based on their position. As I told, these elements, right? I mean, they were elements for which the property was not found, but based on the position, he could tell, okay, this guy will form hydrides in this fashion, this guy will form oxides in this fashion, right? Because if you see, his periodic table is all based on the oxides and hydrides, right? If you see the way it is formed. So, for example, this guy, he has not reacted, he don't know how it reacts. But just because this guy is in group 7, he can say that this guy will form oxides like this. It will be Br2O7, and will form hydrides like this, BH. So that's what the purpose is, right? So in this case, let's suppose it's very difficult to react this guy with oxygen at that point of time. So what he told, okay, I don't know how to react, but I know that this guy La will react with oxygen, it will form something like La2O3. And if this guy reacts with hydrogen, it will form something like LH3. And that was true also. If you react those things in chemistry lab, and you'll see that that was the kind of reaction it goes through, right? So just by looking at the position of the element, for example, Ti. So 10, if it reacts with oxygen, if it reacts, it will form TiO2. and if it reacts with hydrogen, it will form TiH. So those were the kind of things he was able to tell just by looking at the position of the element in the periodic table. Also, he could accommodate noble gas because these gases were discovered at that time only. So once he was done with the table, after that the noble gases were discovered, but he was able to accommodate that. So his table was able to accommodate that. That was one good thing about his table. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.